Okay, so the recording has begun. This is day 3, week number 7 of our journey together. And like I said, it's definitely a delight to have each and every one of you here. So thanks for stopping on by. We continue on our journey with probability. This might be our last installation of probability. We've been in probability for a good while now. And now it's time for the grand finale, which is probability tree. And so we're going to be looking at probability trees for a bit and seeing what can we do with it and what does it entail and how exactly we can answer questions involving probability using the probability tree. All right, so that's going to be our discussion for today. So head up for me, please. Today is Monday, Tuesday, Wednesday. So today is Wednesday, the 17th of August 2022. The subject is mathematics and the topic is probability tree. So let's consider to begin our discussion on probability trees, we begin, or rather we consider the following example. So let's say that excuse me. So let's say that a small box of chocolate contains 8. It contains 8 soft centers. So 8 soft centers, which we're going to denote as S, capital S, and 5 hard centers. So basically we're looking at this box which contains different types of chocolates. Some chocolates have a hard center, and then some chocolates have a soft center. All right. Now, which one you prefer eating? The one with the soft center or the hard center? Sierra, which one you prefer? Chocolates with
Center.
soft or hard, you say?
Center.
Soft center. Okay. How about you, Jasmine? Which one you prefer? Soft center or hard center for the chocolate?
Hard.
Hard, okay. And how about you, Albernique?
I'll say so.
You would say soft, okay. All right, so whatever one you choose, you have these chocolates. One with hard center, which we denote with S, I mean with H, sorry. And the other one with soft center, which we denote as S. Now one chocolate is eaten. One chocolate is eaten, and then
Ah,
hello, okay, and then another chocolate is taken out. So here we have an illustration whereby we have a box of chocolates. It has 8, 9, 10, 11, 12, 13 chocolates inside this box. 8 with soft center and 5 with hard centers. Now one chocolate is taken and eaten, and another chocolate is taken and eaten. Alright, so that is the, excuse me, that's what's going on in this illustration, or in this account, or we'd say in this experiment. That's a better word for it. So how can we um, represent this information on a probability tree? So how can we represent this information on a probability tree? Remember what's happening. We have a box containing 13 chocolates, 8 with soft center and 5 with hard centers. And we're not gonna look, we're gonna close our eyes and we're gonna pick out a chocolate. And then after that, we're gonna take out another chocolate. So you're gonna take out the first chocolate and then we're gonna take out a second chocolate. And so we want to represent this information, or we want to illustrate this information using a probability tree. So the question is, how do we do this? How do we represent this information, or how do we illustrate this information using a probability tree? All right, that's the question. So let's begin. So with this probability tree, this is how it's gonna look. So the first thing is that we gotta realize that we're gonna start off with um, we're gonna start off at this point. Now this point is a very important point. Let me scroll down a bit more. This point right here is a very important point. Let me make a better note of it. So this point is a very important point. It's our first point in our probability tree. So this point is telling us this is at the beginning. So at the beginning we have two options, right? Or two things could happen. The first thing is that we can get a chocolate that has a hard center. All right, that's the first thing that can happen. The second thing that can happen is that we could get a a second outcome is that we can get a chocolate or select a chocolate with a soft center. So pay close attention to this one. So what this is saying is that when we close our eyes and dig our hand inside this box, one possibility is that we could get a chocolate that has a hard center, or we could get a a, a chocolate that has a soft center. All right. Now, what is the probability of us getting a chocolate that has a hard center? All right. So Sierra, what is the probability of us getting a chocolate that has a hard center?
4/5.
Say it again.
4/5.
Why you say 4/5?
Because it's a hard center and then it's 5 hard centers, and if we get one of them, it'll be 4.
So we want the probability of getting one hard center though. So how much chocolate we have in general?
Oh, 13.
13. Okay. So we know that we have 13 um, chocolates in general. And how much ones have a hard center?
5.
5. So the probability of getting a chocolate that has a hard center is 5 out of 13. Okay. Maybe I should use a different color to denote that. So this is gonna be 5 out of 13. Now, what's the probability of getting, Deja? What's the probability of getting a chocolate that has a soft center?
That'd be 8/13.
8 over 13. 8 over 13 because there are 8 chocolates. 8 chocolates that have soft centers out of 13. Okay.
But I don't understand something. This says that it's eaten. So wouldn't that mean like you take it out and you didn't put it back?
But we just wonder. Remember, you're going ahead of yourself. We just want the probability of choosing one, right? Now we haven't. Now they are not eaten yet. We just want the probability that we could get a we just want the probability that we can get one that has a soft center. All right. So that this is not like the one where you have the not replace thing. No, we just looking at it and we just saying, okay, at the beginning with our first with us taking our hand randomly inside that box, our eyes are closed. What is the probability that we can get one with a hard center? What's the probability that we can get a chocolate that is soft center? All right. So we don't assume that one is taken out already. All right. So be careful of that. So now that this is the first what should I say? This is the first part of our probability tree. Now we're gonna continue it. So we already get let's assume that the first one that we got was the first chocolate that we got out of the bag was hard chocolate. After that we can get one that has after that we can get a chocolate that has either a hard center which we're going to denote as H, or a soft center, which we're going to denote as S. Similarly, after we get a soft-centered chocolate, we can get one that has a hard center, which we're going to denote as H, and one that has a soft center, which we're going to denote as S. So what is happening here? Well, what is happening here is that we are basically listing out all of the things that could possibly happen. So what is the probability of me getting a hard centered chocolate? But remember, I already took one out of the bag because my first one is already taken out. So now I'm on my second one. So now that means I only have 12 inside that means I only have 12 chocolates inside my box. So I only have 12 chocolates inside the box. And how many hard centered chocolates do I have? Well, I already took one out. So I am left with 4.
Take one of both of them.
Well, I already took one out. I already took one hard chocolate out. So that's why I only have 4 left. Because remember, it was what, 5 hard centered chocolates. I took one out, so I am left with 4. And there are 12 chocolates inside this basket left. So it's 4 out of 12. Now, the idea here is that what you're basically trying to do is, if you want to figure out what is this probability, like what's the probability of this one, like right here, you're just basically gonna figure out what could you do to add up to get 12. So what number plus 4 gives me 12? Again, what number plus 4 gives me 12? No. What number plus 4 gives me 12?
5.
8. So if I add 8 to 12, I'm going to get 8 to 4, I'm going to get 12. So the probability of me getting a soft center one is going to be 8 out of 12. Now let's go to this one. So assume that I get yes, mom?
Did you take one of the bags and so like you could be like 7 or 12?
Say it again?
So you say you take one of the bag, right?
Yeah.
So ain't that supposed to be like 7 or 12?
Okay. Very good question. Remember, the one that I took out was a hard centered one. I didn't take out a soft center one. So I still have 8 soft centered ones. I didn't take out a soft one. I took out a hard one. So that's why I still have 8, yeah. Okay. Yeah, I took out a hard one, yeah. Alright, so now with this one, we notice that for this one, we took out a soft centered chocolate, and then we're gonna take out another soft centered chocolate. So that means that we're supposed to have 7 soft centered, because remember the first time we took it, we took out a soft centered one, so it's going to be 7 out of 12. And what plus 7 gives me 12? Well, that's going to be 5. So 5 over 12. Okay. And that's basically how we complete the probability table. So now, what if I want the probability? What if I want the probability that I get a a hard-centered chocolate and a hard-centered chocolate. So both of them were hard-centered chocolates. Okay. So remember, with this one, if I want a hard-centered chocolate and a hard-centered chocolate, that's going to be the multiplication rule. So I'm going to have to follow this line. So I want a hard-centered chocolate, and I also want a hard-centered chocolate. So I want a hard-centered chocolate for the first one, and I want a hard-centered chocolate for the second one. So that's going to be 5 over 13 multiplied by 4 over 13. Sorry, 4 over 12. Okay. 5 times 4 is 20. 12 times 13 is what? What is 12 times 13?
156.
156. Very good. 156. And if we reduce it, that could be reduced to, you could use multiple things. You could use 2 if you want to reduce it. You could use, see if we could use 4. Excuse me. You could use 4. Yeah, so let's use 4. So divide top and bottom by 4. So 20 divided by 4 is 5. And 156 divided by 4 is 39. So it's a probability that I get a head first and a head not a head, sorry. A hard-centered chocolate first and a hard-centered chocolate second.
What if we get both?
Say it again?
Like, what if we get both?
Like, what you mean?
Like, if we have a hard center and a soft center.
Good, very good. So let's say that I get a probability that I get a hard-centered first and then a soft-centered second. So that means that the first thing I got was a hard-centered one. So the probability of getting a hard-centered one was 5 out of 13. And then I want a soft-centered, so I gotta go to this one, soft-centered. So I multiply that by 8 over 12, because that's what it is for, soft-centered. 8 over 12. This is gonna be 5 times 8, which is 40, over 156. Is gonna be equal to 10 over 39. Because if I divide the top by 4 and the bottom by 4. Now what if I want the probability of both of them being soft-centered? So if I want both of them to be soft-centered, that means that I would go here. Probability of soft-centered is going to be equal to 8 over 13 multiplied by probability of me getting a soft-centered again is going to be 7 over 13. Sorry, 7 over 12.
Excuse me.
Go ahead.
So you're supposed to go from different one to this one?
Say it again.
If you're supposed to go from this one to this one.
Yeah, so because remember, it's soft, soft. So I have to go from soft to soft. Okay, I want
This is soft, right?
Say it again.
But that one is a soft right there.
Which one is a soft?
The one go 8/12.
Okay, very good. Remember, the one that going from 8/12, that's connected to the hard first. Okay? So I can't go soft, then I go to this soft. I have to go soft, then soft, because this one that's here, it's connected to the H. Okay? That means I got the hard first, so I can't do that one. I have to go soft first, then soft. Okay? So that's how it's supposed to go. So 8 times 7 is what? What is 8 times 7? 56. And what is 12 times 13?
156.
156. Very good. Right, so we divide by 4. So divide top and bottom by 4. This is going to be equal to 56 divided by 4 is 14. All over 39. Any questions for me? Any questions for me?
It's just complicated.
It's complicated. What's complicated about it?
Everything.
Everything? Oh my goodness. Ah boy. Okay, let's see if we can break it down some more. Um, so what's happening here? The first thing is we start off with nothing inside. Well, we start off with our hands outside the bag. We could either get a hard chocolate, a hard scented chocolate, or we could get a soft scented chocolate. That's the options that we have. After we get a hard scented chocolate, we either could get a hard scented chocolate again, or we get a soft scented chocolate again, because we getting two chocolates. So the first one could be a hard chocolate, and the second one a hard chocolate, or the first one could be a hard chocolate, and the second one a soft scented chocolate, or we could have the first one being a soft scented chocolate, and the second one be a hard scented chocolate, or we could have the first one being a soft scented chocolate and the second one being a soft scented chocolate. So this tree basically is telling us the different you know possibilities that we could have. Okay, now if we want the possibility that we get a hard scented chocolate and a hard scented chocolate, well, we know that the probability of getting a hard scented chocolate is 5/13. We know that we are multiplying because it's a hard centered and a hard centered. So it's going to be 5/13 times 4/12. And then we want a hard centered chocolate and a soft centered chocolate. So it's going to be 5/13 times what? 8/12, because hard centered, soft centered. And then we want soft centered and soft centered. So it's going to be 8/13 times 7/12. Okay, and so that's how we I guess read it and understand it. Okay.
Excuse me.
Go ahead.
Is it like possible if we have it in heads and tails?
Say it again.
Like, is it possible if we had it in heads and tails?
Yeah, that could work. So if you are rolling a dice twice, not dice, but rolling tossing a coin twice, that could happen. So that would be one of your that'd be a way you could use this tree. Okay,
Excuse me.
go ahead.
Do you also divide it by 4?
In this case, 4 is the best number, but you could use 2 first, and then after 2 you can divide it again using another number. But 4 simplifies it all the way for us immediately. So that's why we use 4.
Thanks.
No problem. Any other questions for me? No? So that means that we all get it. Alright. Okay, so okay, let's move on. So let me clear this drawings. Okay, I had some more things on this to show you all, but I think that I'll pause for now with probability trees because it seems to me that it's a bit challenging for you all. Um, so maybe the case may be that you need to see a bit more other math before you get ready for this. Maybe that's the case. So I'll hold off on this topic, on diving into this topic some more, because I feel like the more I go into this, the deeper you drown, and I don't want no one drowning in there. Um, so we're gonna stop right there for probability trees. I ain't gonna push it further than this. There's one more thing that we would probably need to do for probability trees, and that's dealing with OR when you have the addition rule, but I'm not gonna push that because I think that the level of difficulty is becoming uh, too great. So with that being said, we have to move on to something else. So let's move on to section 2. And for this one, we're gonna be looking at um, I want us to look at fractions on a number line. Okay, So fractions on a number line. So I think probably the best thing for us to do is to okay. So let's consider this example. So let's assume, right, that we have this line. And this is a line that we have. So this is going to be our number line for the day, right? And on this number line, we have, we're going to basically divide this number line equally. One moment. All right, so we want to divide this number line equally. All right, so let's say that we have 0. Let's say that this number here was, say, 1/8. Let's say that the other number that we had, let's say that this one, we have no numbering for it, but let's say that this one, we have a number, and let's say this is 3/8. Let's say we have this one, no, nothing for that, and let's say that for this one, we have the number B, sorry, the letter B. And so for here, we have nothing, and then for here, we have 7/8. And so my question here is the following. My question is, I want you to write a fraction, or write the fraction really, that B represents. Right, so write the fraction that B represents. So what would B be? So beginning with you, Altonique, what you think B is gonna be? What fraction is B gonna be?
3/8.
3/8? No, that's not correct. How about you, Mr. Jonathan Linton? What do you think B is gonna be? What fraction B is gonna be?
5/8.
5/8. Okay, anyone agree with Linton? That is 5/8?
Yes.
Yeah, okay. How do you know it's 5/8?
Because 1, and then the next one would be 2, then the next one would be 3, next one would be 4, and then B would be 5.
Very good. Very good. So B represents the fraction 5/8. So with this one, or with this example, this is showing us how to locate fractions on the number line. So even though they skip certain ones, this is actually 1 over 8. This is actually 2 over 8. This is 3 over 8. This is 4 over 8. This is 5 over 8. This one is 6 over 8. And this one is 7 over 8. So the fraction that B represents is definitely going to be 5 over 8. Okay, so let's consider some other examples concerning this. So exercise number 1. So in each case, determine or write, sorry, the fraction that B represents. So let's begin with, we're going to have 5 of these. So let's begin with A. So let's begin with, well, let's write number 1. So if we have the number line, so if we have the number line, and this one is 0, this one is 1 over 9. We don't have idea what this one is. This one is 3 over 9. We don't know what this one is. This one is B. For this one, we don't know. This one is 7 over 9. So right on this line, what is the value of B? Number 2. Again, if I have 0, this time I have 1 over 7, 3 over 7. This is B. This one is 7 over 7. This one is 9 over 7. So what is the value of B? Number 3. If I have this one is 0, 1 over 5. This B. We don't know what that is. This one is 5 over 5. 6 over 5. Write the value of b. Number 4. If I have 0, 1 over 6, 3 over 6, 6b, 7 out of 6. And the fifth one and final one is if I have 0, this is b, 3 out of 4, 4 out of 4. That is b. Okay, so I'm going to give you how much time I should give you? 1 minute?
Yeah.
All right, so let's attack it.
5 minutes.
5 minutes? Say 5. Oh no, not 5 minutes. All right, I give you 1 minute. I don't think this definitely ain't as hard as the tree. So let's tackle this quickly. All right, that's time. Someone on Almanic, your hand is up.
I can answer the second one.
Okay, sure, no problem.
Answer the first.
All right, go ahead, Altonic. What's the first one?
First one is 5/7
The first one is 5 over 7.
over 9.
5 over 9, very good. 5 over 9. What's the second one?
5 over 7.
5 over 7, that's correct. What's the third one?
I could do it.
No, I want Miss Neely.
3 over 5.
3 over 5. Kiara Linton, do number 4, please.
5 over 6.
5 over 6. And Jasmine, can you do number 5? Say it again.
1 over 4.
Go ahead, Jasmine.
1 over 4.
1 over 4. Okay, 1 over 4. Very good. All right, so when you're writing fractions on the number line, and you don't have all of the numbers there, what you have to use context clues to figure out which one you're gonna actually do. where, I just say you use context clues to figure out where exactly that number that you're looking for lies. So if it is after 4 but before 6, then you know it's 5. All right, so you use context clues to figure out exactly what's happening there. So any questions on this?
Also,
Okay. So the next thing I want us to look at is, sorry, that's also important, is let me move this. So okay, so this one is section 3. Section number 3, and here we're going to be looking at cross multiplying. All right, so sorry, I spelled that wrong. So to illustrate the need of cross multiplying, when solving linear equations, we begin with the following example. So let's say, for example, you have this equation. So let's say you have k over 4, and that's equal to 5 over 6. Right, so you have k over 4, and that's equal to 5 over 6. All right, so in order to solve this, what technique would we use, Sierra?
We have to find the common factor that can go in 4 and 6.
Nope. I mean, that's one way you could work, but the hint is in the title.
Oh, 4 times 5 and 6 times k.
Very good. So we're gonna cross multiply. So in order to solve this, we're gonna multiply the 4 by the 5 and multiply the 6 by the k. And we call that cross multiplying. So it's gonna be So the next line that we have is going to be 6 times k. Okay, that's going to be equal to 4 times 5, which is what? 20, right? And so now we have 6k is equal to 20. Now what do we do? Go ahead. Yes, ma'am.
What does K mean?
What does k? Okay, so k is the variable that we are trying to solve. We're trying to find the answer for k. All right. K is the variable or the letter that we're trying to solve. We're trying to find an answer to. All right. So once we figure out, now k represents a number. So once you find to figure out, and you could kind of see already what it's k, like. So what times 6 give me 20? That's basically that accent.
5.
No, not 5. Definitely not 5. So 6 times k
4.
is, no. 6 times k is 6k, and 4 times 5 is 20. Good. Now we're going to divide both sides by 6. So it's going to be 6k equals to 20. Then we can divide both sides by 6. So after we divide both sides by 6, we know 6 divided by 6 is k, and 20 divided by 6 is what? What is 20 divided by 6?
3.33.
That's if you represent it in terms of a decimal. So 6 into 20 goes how much times? 6 goes into 20 3 times. So 6 times 3 is 18. So 20 minus 18 is 2. So we are left with what? 2 and 3 and 3. We are left with 3 and 2 over 6, which is 3 and what? 1 over 3. So k is 3 and 1 over 3. So that's how we find the value for k. So in order to figure out what k is, we had to what? Cross multiply. So we had to multiply the 6 by the k, multiply the 4 by the 5. Once we get that, we would have 6 times k, which gives us
I don't get it.
6k. And then we have 6k equals to 20. We divide top and bottom by 6. So we divide each bottom by 6. And so that means 6 times 6 is k. And 20 divided by 6 is 3 and 2 over 6. All right. So someone said that they didn't get it, so we can do another example to explain it some more. All right, so let's do another example. So let's say we had, so the instruction here is to simplify the following equation. that's our goal. And remember the technique that we're trying to use. We're trying to use the technique of cross multiplication. So here we have again k over, excuse me, so we have k over, it's going to be equal to 7. And I say that in the bottom we have 6 times 6 and let's say that this is 4 to make it easier. Let's say that this is 8. Okay, good. So you have k over 6 equals to 8 over 4. Okay, what's the first step that we must do? What's the first step?
You ask anybody?
Yeah, anyone? Yeah, cross multiply. So Jasmine, we're gonna multiply the 6 by the what? By what?
8.
6 multiplied by 8. And Jonathan, what are we gonna multiply the 4 by?
8.
K, very good. The 4 by the k. So 6 times 8, 4 times k. Good. Deja, what do we get when we multiply 4 times k?
Pardon?
What do we get when we multiply 4 times k?
Okay.
4k. What is 6 times 8? Kiara Linton.
48.
48, very good. Okay, good. Now, after we reach this step, there's a next step. What's the next step that we do after this point? Anyone can answer? What do we do? Sierra, what do we do at this point?
Okay, so it would be K. No, you divide 4 on both sides.
Divide 4 on both sides. Very good.
Okay. K equals 12.
K equals to 12. How did you get 12?
Because 48 divided by 4 gives you 12.
Very good. So K equals to 12. So if we were to divide 48 and if we were to divide 48 by 4, we know that 4 goes into itself once. So that's 4. It is 0. Bring down the 8. 4 goes into 8 2 times. So 4 times 2 is 8. And by the way, we don't even have to do this because this is part of the multiplication table. So, sorry, this is supposed to be 0. So, k equals to 12. Right? Albanic, do you understand it better now?
Yes, sir.
Right. So we're going to do another example. All right, so let's look at another one. So again, here we want to simplify the equation. So we're going to use k again, all over. It's going to be equal to, let's say we have 5. Let's say we have 10. And this is 4. Alright, so can someone tell me what's the first step that I do?
We have to cross multiply.
Have the cross multiply. Very good. So, my apologies. Kiara Lenton, what must we multiply the 5 by?
K.
Okay. Jonathan, what must we multiply the 10 by?
4.
4. Very good. So 5 times k, 10 times 4. That's going to give us 5k, which equals to, what is 10 times 4?
40.
40. Right, what's the next step for this?
I think you have to
So
divide 4k by 4.
by 4? Why by 4?
I mean by 5.
By 5. Very good. So we divide 5k by 5. And divide 40 by 5. So these two cancel out. So k is going to be equal to 40 divided by 5 is what?
8.
Very good. It's 8. So k is equal to 8. And that's our answer. So this is using the technique of cross multiplying. So you take this number, multiply it by that, take this number, multiply it by that, cross multiply, and you get your final answer by dividing after you finish divide. Alright, so let's do some exercises based on this. Simplify. Simplify the following equations using, equations by cross multiplication. The first one is K over equals to 4, 9, 6. Alright, so just those 5. I'm gonna give you 2 minutes for that, and then we can check them over after the break. So 2 minutes, and the time has begun. Remember, we're trying to solve these linear equations using cross multiplication. Excuse me. Excuse me. All right, that's time. All right, Sierra, what did you get for number one?
Can I do number one?
Oh shoot.
I already called Sierra. You could go out. You could do number two.
Okay, for number one, I got 6.
6K is 6.
Yes, sir.
All right.
Explain how I get it.
Yeah, explain how you got it.
Okay, so we cross multiplying. So 4 multiplied by 9, which give me 36, and then k multiplied by 6, which give me 6k. 6k over 6 equals 36 over 6. K equals 6 because 36 divided by 6, by 6 is 6.
That's a
I
lot
can
of
do the next
sixes.
one.
That's a lot of sixes.
It is. I can do the next one.
You could do number three, Jasmine. Albanique doing number two.
Okay.
All right. So um let's review what we did here for this one. So this is k over 4 equals to 9 over 6. And like we said, we cross multiply. 6 times k is 6k. And that's going to be equal to 4 times 9, which is 36. Divide both sides by 6. We get that k is equal to 36 divided by 6 is 6. So k is 6. That's absolutely correct. Go ahead, Albernique, for number two.
Alternate asked to go.
Oh, Altonic asked to go. I thought that was you. All right. Go ahead.
I got 6.
For number two?
Yes, sir.
All right. Anyone else got 6 for number two?
I did.
I also got it.
I did.
Okay. All right. So let's do it. So k over 4 equals to 12 over 8. So 4 times 12, 8 times k. So 8 times k is definitely 8k. And it's going to be 4 times 12, which is what? 48. Divide both sides by 8. We get that k is equal to 6. Okay. Very good. Y'all some real mathematicians today. I don't know, y'all didn't like probability, eh?
No, sir.
Oh,
That was a no.
oh my goodness. And I know one person liked probability. At least one. And that was Deja.
Huh? I mean, I don't hate it, but I mean, I can't run away from it. At least not me. Those on grade 7, they don't really have to worry with that. But
Yeah,
I can't run away from it.
but we can't run away from that. Not at all. Not at all, sis. Not at all. Um, k over 10. Oh, Jasmine has to do number 3. Go ahead, Jasmine. What you got for number 3?
I get 6.
6. Okay, let's try it. So we have k over 10.
I do it like over my head, then I write it down.
Okay, so let's see if that mental math worked. So k over 10 equals to 3 over 5. We multiply 10 times 3, which is going to give us 30. K times 5, which is 5k. Yep, divide by 5 on both ends. We get that k is equal to 30 divided by 5, which is 6. Very good, that's true. Wait, all the answers is 6 thus far? Wow, I didn't realize that. Alright, number 4. Jonathan, what you get for number 4?
4. No. 5. Oh,
I get barely hear you. Say it again.
no. Number 5 got 2.
For number 5, you say you got 2.
No.
I mean, number 4, sorry, you got 2.
Number 4 I got.
Okay, so b over 3. Now, even though we changed the letter, the same thing still applies, right? So don't mind about the letter change. 6 over 9. 3 times 6. 9 times b. That's 9b. It's going to be equal to 6 times 3 is 18. Divide both sides by 9. We get b is equal to 18 divided by 2. 18 divided by 9, which is 2. Very good. Alright, so number 5. Taisha Johnson. Miss Johnson, what do you get for number 5? Miss Johnson, what do you get for number 5?
4.
4. Okay. So let's see. So we have h over 12. So h over 14 equals to 2 over 7. We cross multiply. We have 7 times h, which is 7h. It's going to be equal to 2 times 14, which is what? 28. Divide both sides by 7. We get h is equal to 4. So the answers are 4, 2, 6, 6, and 6. Right? Anyone got 5 out of 5? 4 out of 5?
5
Okay, 5 out of 5. Alright. Alright, so let me know when you finish with this. Are we good?
So,
Okay. Alright, so let's look at section, what section we are now? We did section 1, which was probability 3, tree, And then section 2 was fractions on a number line. And now I want to look at section 3, which we're going to look at percentages and real world application of it. Okay. So section 3. So percentages and population. Okay, so basically gonna look at a real world application of percentages. Percentages are useful or associated with many real world situations to illustrate this idea. We consider the following question. Suppose that the number of female students registered at the University of the Bahamas is 1,197. And suppose further that this amount represents 63% of the total student population. Calculate our goal is to calculate the total student population from this information given. But how? Okay, so we have an interesting question before us, right? So, Sierra, can you read this for me, please?
Okay. Percentages are associated with many real-world situations. To illustrate this idea, we consider the following question. Suppose that the number of female students registered at the University of the Bahamas is 1,197, and suppose further that this amount represents 63% of the total student population. Our goal is to calculate the total student population from this information given.
Yeah, but how? All right, so any ideas? how can we know how much girls we have. We know that that's 63% of the population. How can we figure out what is the total student population? Any ideas?
Like traveling.
Say it again.
Search up on Google.
No, say search on Google. No. No, we want to actually do it using math. So how can we figure out what is the total student population? Any ideas?
It's 63% over 100 times 119 over 1.
Mm, Deja, do you agree with that?
I mean, at first I was gonna say the same thing, but then I just read that 1,197 that you said is the amongst female students, and then it's just
Exactly.
saying that 62% represents that, so we can't use that.
Exactly. Very good. So,
What if we just hold on? This sounds crazy, but what if we just subtract 63 from 100, and then that don't even make sense? What if we times it by 2? Never mind.
exactly. So this is a very good question. So, normally if we have questions like this, right? The method that you said, Sierra, would have worked, right? So all we need to do is say 63 over 100, multiply that by 1,197, and that would give us the answer. But the problem is 63% is equal to 1,197. So they're saying that, so think about it. So imagine if the total amount student population is say, we could represent it using a pie chart, right? So we know that there are going to be two genders, male and female, right? So we have, so this is not right. We have 63%. So half is straight down the middle. 63% is going to be more than half. So let's say it's something like that, right? So we know that 100 minus 63 is how much? That's 10, that's 9, that's 7, that's 2, so 27%. So 27% here is your males, right? And we know that 63% is
It's 37.
37. 37. Oh, 37. Thank you. Not 27. Thank you, because yeah, I was thinking, yeah, that's right. 37. So 37% is males, 63% is females, right? So, Albrecht, are there more females or more males inside this university?
More females.
There are more females, right? In fact, there are way more females than males in this university, right? And that's typically the case. Usually, there are more females in college than males in college, right? I remember in some classes, I was the only male inside the class when I was in university. So, yeah, sometimes it's like that. So there are 63% females, so way more females than males. Now, the idea here is that when you find questions like these, what they tell us is that 63%, right, is 1,197, right? That's what it is, right? So that 63% is that number, right? 63% represents that number. 1,197. But
I don't get it.
yeah, I understand. That's fine. Give me a moment to explain it first. Right? Then you can understand it. So 63% represents this number, 1,197, of the population. So the population consists of males and females. We already know that 63% is for the females. What we're trying to figure out is how much students are actually inside this entire school, right? Now the idea is this. So this is how you basically could answer this question. So what you're gonna do is you're gonna say, okay, just like how Sierra said, if I have my total, so let's say that the amount of students the total amount of students that we um, that we have in the school, let's represent that by capital T. So let me erase this. I don't need this no more. Let's say that the total amount of students inside the school, we're gonna represent that by capital T. So capital T, let's just use small t. So small t represents the total amount of students that I have inside the school. Now I have them multiplied up by 63 over 100. Now if I knew what this total was, right? If I knew what this total was, then that was going to give me how much female students. But the good thing is that they already give that to us. So that's 1,197. So essentially what this is that you basically have to, in order to solve this question, you have to solve for t. You have to figure out what t is. All right? Because 63 over 100 multiplied by the total is going to give you the amount of girls. But we already know about the amount of girls. The amount of girls is 1,197. So when you have questions like this, what you're going to do is you're going to take 63 divided by 100 and multiply it by t, the total. We don't know what it is. We're trying to figure that out. And equal it to 1,197. So basically, what is 63 divided by 100? That's going to be what? 0 point what? You all know? 63 divided by 100. You must send that twice. 1, 2. That's going to be 0 0.63.
I was just gonna say that.
Yeah, multiplied by t. Okay, and this is going to be equal to 1,197. Now, once we reach to this point, we have to divide top and bottom by, not top and bottom, both sides by 0 0.63. So divide by 0 0.63. So divide by 0 0.63. And so that means that the total is going to be equal to 1,197 divided by 0 0.63. Now, how do we divide 0 0.63 by, 1,197 by 0 0.63? That's the question.
Pardon?
How do we divide 1,197 by 0 0.63? So the idea here is that
I know you have to multiply by 100 and then you move decimal point and then you divide regularly.
you could do that to save you a lot of time. That'll save you. So what we do here is we multiply top and bottom by 100. The reason why we do this is because this is 0 0.63, right? So let me set it up for you. So what we essentially have is 0.63, and that's gonna, and 1187 is gonna be divided by that. But in order to, we don't know our 0.63 timetables. At least I don't know it. So we're going to transform this question into a question where, by multiplying by 100, we're going to transform this question into a question where we have 63 divided by, 1187 divided by 63. So it's going to be 1197, and then we're going to add 2 zeros at the back, 0, 0. All right, and so what we have is 63 divided by 119700. And so now we ask ourselves, how much times 63 goes into 1,100, 1,000, not 1,000, that's 1,197,000. Am I saying that right? That's 119,700. Okay, so we can try 1. Well, 63 times 1 is 63. So that's going to be 119 minus 63. 9 minus 3 is what? 6. And 11 minus 6 is 4. We bring down the 7. And then we have 4, 6, 7.
No,
If we-
11 minus 6 is 5.
Yeah, 5. Thank you. 5. Thank you for the observation. So 5. So we have 5, 6, 7. We could use 9. So if we look at 63 times 9, we get what? 63 times 9 is exactly 5, 6, 7. And so this is going to be 0, 0, 0. And you bring down the 0. So you put a 0 here. Minus 0. And you bring down a 0 here. And you put a 0 there. Okay, so basically, how do we answer this question? If I give you another question like this, the only thing that you need to do, so if I have 63, right, percent, the only thing you need to do is you need to what? Take 63 and divide it by this number, but only thing, add the 2 zeros. Okay, so that's how you answer a question like this. You would take 63 and divided by, so you would take this number with 2 zeros and divide it by 63. Okay, so that's how we're gonna answer this question once I give it the next time. So you don't have to worry about doing all of this, because you know that at the end of the day, all you have to do is divide 63 and 1197, but this time with the 2 zeros in the back. Okay, so that's, yeah. What I'm saying is, when you have a question like this, you would take this number, add 2 zeros in the back, and divide it by 63. Just like how we did this. Okay? So let's look at another question so you can understand how to do it. The only thing is you have to be able to divide 63 by whatever number that I give you. Alright, so let's do another question. So this is Example number 2. So the number of female students registered at Allen Coakley High School is 126. This represents 63% of the total student population. Calculate the total student population. Alright, so this is example 2. Alright, so what's the first thing that we're going to do for this question? Sierra, the first thing we're going to do?
Oh, okay. 63 over 100 times t equals 126.
We ain't got to go through all that.
Oh,
Just the major thing. What we going to divide?
okay. We're going to divide 63 by 126.
126? You sure? 126?
126.
126? Just 126?
No, with the 2 zeros.
With the 2 zeros. Very good. Okay, so divide that and let me know what you all get. So you have to divide 126,000 by 63. And what do you get? No one get the answer yet?
Oh, 200.
200? Who said
So,
that?
Sierra.
Okay. Alright, that's absolutely correct because 63, if we multiply 63 by 2, that gives us 126. And we subtract 6 minus 6 is 0, 2 minus 2 is 0, 1 minus 1 is 0. We bring down the 0. So also bring up the 0. So it's going to be 63 times 0, which is 0. We bring down the 0 here as well. And so we have 0 minus 0. Okay? So the answer for the total amount of students in the population is going to be 200. Okay, so take that down and then we're going to look at another one so you can get a hang of it. All right, so let's look at this question. So example 3. The number of female students registered at R.M. Bailey Senior High School is 189. This represents 63% of the population. Of the total student population. Registered. Calculate the total student population. Alright, so it's our third example. Okay, go ahead, Albanic. What is the first thing I should do?
Divide 63 by 186, and you have to put 2 zeros at the end.
Very good. So we have 63. We divide that by 189, but you have to put 2 zeros at the end. All right. And so once you divide that, let me know what you get. Once you get the answer, let me know what you get. Jonathan, did you get anything? What's your answer for 63? 189,000 divided by 63.
No, sir, not yet.
Not yet? Okay. Sorry, that's 18,900. Sorry. Teach what you get.
You asking me?
Yeah, you're asking you.
300.
300. Why you sound surprised?
Pardon?
I say, why you sound surprised?
Surprised?
Yeah.
Am I?
I say, you asking me? Or you just, that was a genuine question.
No, sometimes I mistake you calling me for someone else.
Oh, okay, okay. Okay, so 63 times 3 gives us 189. Okay. And 189 minus 189 is 0. You bring down the 0. That's going to be 0 there. Minus 0. And we bring down the 0 again. And that's 0 up top. Zero minus 0 is 0. So the total amount of students in the population is going to be 300 students. All right. So do we understand how to do these questions? Questions like this? Mm-hmm. Yes, no, maybe so. All right, let's look at another one. Let's do an actual exercise. Okay, so yeah, I'm gonna actually do an exercise. Let's see how we fare with this exercise. Okay, so um so exercise number, I guess it's number 3, I think. So for this one, I'm only gonna ask you 2 questions. So the number of female students registered at the college is 63. This represents 63% of the total student population. Calculate the total student population. That's A. B is the number of female students registered at Oakwood University University is 252. This represents 63% of the total student population. Calculate the total student population. All right, now for this one, I'm going to give you 3 minutes, and then we can do it together. All right, there we go. And the timer has begun.
No, I could go.
Um, 100.
Yes, sir.
Okay.
Okay, so 63 divided by 6300.
Four hundred.
Yes, sir.
Yes, sir. Maybe next time. But you didn't mean I didn't get on number two, right? I got number one and I got on number two. thought out and perfect. Yes, when you grateful for something, when you thankful for
She stepped out to the bathroom. Um, pass it on. Pass it on. Yeah,
Uh, I guess a group of civilization. I guess a group of people in a community or in a society.
Way of life or something.
Yes, sir. Can you repeat?
Prosperity. Um, yes, sir. I think they know. Um, like success.
Pardon? Yeah, I agree with a place or a time of great success.
Yes, sir. Pretentious means good at something. Fake. Well known. Okay. To pretend to know something or something is fake.
Oh boy. What? You said equanimity? When I hear equa, I think equal. Maybe equality. Yeah. Maybe equality or fairness. Never heard that word before. So you're saying they're nonchalant? So they're a peaceful person. Well, I need some equanimity.
Yes, sir. Center.
That is what.
Me too.
You could pass it on.
Genuine. Also say that. Genuine. What? Um, not too sure. I'm too sure with that word. Take pass it on.
I could try. When I hear abstinence, I think about like, oh, what do they call it? Contraceptives. Like when I hear abstinence, I hear sexual abstinence. Like abstinence means to stop or to keep away from or to not do.
Oh, like declining or something.
Give someone a hint or something? You can give me a hint. Something that is what?
When you think you can't do something, okay, right?
Delay from something. I think I know definition. Like hindrance is something like is something bad, like coming bad from something or somebody, like an obstacle or a blockage. Yes. I know I heard this word before. Or break or something. Obstacles.
Like going around something.
Yeah, good night.
Bye.